Okay, this is an absolutely fantastic question for testing complex and real solutions to trigonometric equations. Okay, so we got 2 tan squared theta adds 2 sine squared theta equals 3. What we're going to use is we're going to use sine squared theta add cos squared theta equals 1, and tan squared theta add 1 equals sec squared theta. So sticking them in, we get 2 sec squared theta minus 1 add 2, 1 minus cos squared theta equals 3, i.e. 2 over cos squared theta, 1 over sec squared is 1 over cos squared, minus 2 cos squared theta equals 3. And this is going to give us a quadratic in cos squared. 2 cos to the 4 theta add 3 cos squared theta minus 2 equals 0, which we can now factorise as 2 cos squared theta minus 1 cos squared theta add 2 equals 0. Okay, and here we're going to get the real solutions, and here we're going to get the much more complex, complicated complex solutions. So let's do the real solutions first, i.e. cos squared theta equals a half. That comes from here, so therefore cos theta equals plus or minus 1 over root 2, using our all stations to crew. As cos theta can be plus or minus 1 over root 2, then it takes all of these values, and therefore our real solutions are theta is pi over 4 add 2 pi n, where obviously 2 pi n is going round the full circle, or theta, that's pi over 4. This one here, 3 pi over 4 add 2 pi n, 5 pi over 4 add 2 pi n, or 7 pi over 4 add 2 pi n, and they are the real solutions. And to be honest, that's fairly straightforward. Let's go on to this bit, which gives us our complex solutions. So we have cos squared theta equals minus 2, i.e. cos theta equals plus or minus root 2 I. Now, in a previous video, we discussed how to solve cos theta equals 3, and you can find the link to that video in the description to this video. And in that video we discussed that cos theta can be written as e to the I theta add e to the minus I theta over 2. Go and check out that video if you don't know what that means, but anyway, we can use the same method here. Plus or minus root 2i equals e to the I theta add e to the minus I theta over 2. And now what we do, let's just let e to the I theta equal u. It just makes it slightly easier, and therefore we have plus or minus root 2i equals u add 1 over u, plus or minus 2 root 2i, because we're just moving the 2 up there, gives us u add 1 over u, i.e. then we get a quadratic in u squared plus or minus 2 root 2i u plus 1 equals 0. And this is the quadratic that we now need to solve, and we're going to use the quadratic formula to solve this. So therefore u equals minus b, well minus b is going to be plus or minus 2 root 2i, that bit there is b, plus or minus the square root, and here we have to be really careful. B squared is this thing here, squared, which is going to be 8i squared, and I squared is minus 1, so it's going to be minus 8 minus 4ac, which is minus 4, all over 2, i.e. we have that u equals plus or minus 2 root 2i plus or minus, well that is the root of minus 12, which is I times 2 root 3 over 2, which gives us that u equals plus or minus I root 2 plus or minus root 3. Okay, now things get even more complicated from here. So now that we have, u was basically e to the I theta, so now that we have that e to the I theta is equal to plus or minus I root 2 plus or minus root 3. Okay, so how are we going to solve this? Well, we're going to take log, so that means that I theta equals log of plus or minus I add log of root 2 plus or minus root 3. All we've done is taking logs of that. And now we need the log of plus or minus I. Well, let's just have a quick look at an Argand diagram. Here is I here, and here is minus I, and that obviously is pi over 2, and this is 3 pi over 2. So I can be written as e to the I pi over 2, and minus I can be written as e to the I 3 pi over 2, and therefore the log of I is I pi over 2, and the log of minus I is 3 pi over 2. And so therefore what we get is we get that the log of I, so therefore we get that I theta is either equal to, depending on whether we're going to take plus or minus I pi over 2, which is that log, plus log of root 2 plus or minus root 3. That's one of them. And let's just do the other one here. Or I theta equals 3 pi I over 2, which is this log here, plus log of root 2 plus root 3. So these are the two different complex solutions. We can divide by I now, and that gives us that theta equals pi over 2 add log of root 2 plus or minus root 3 over I, or theta equals 3 pi over 2 add log of root 2 add root 3 over I, and we're getting there. Now, just to tidy stuff up a little bit, let's just do a little bit of a sidetrack. Root 2 plus root 3 squared is equal to 2 plus 2 root 6 plus 3, which equals 5 plus 2 root 6. And likewise, root 2 minus root 3 squared is equal to 5 minus 2 root 6. So therefore, root 2 plus root 3 and root 2 minus root 3 are equal to the square root of those respectively. So we can stick those in. It just tidies things up a little bit. So basically, we now have that theta equals pi over 2 add log of 5 plus or minus 2 root 6 to the half over I, or theta equals 3 pi over 2 add log of 5 plus or minus 2 root 6 to the half over I. And we're almost there now. We're just going to have to go on the next page. So all we need to do now is just multiply top and bottom here by I, and multiply top and bottom here by I, and then I times I is minus 1. So therefore our two complex solutions are theta equals pi over 2, and let's add in the general thing as well, add 2 pi n, because obviously that's any multiple of 2 pi also is a solution. We've got pi over 2, add 2 pi n, minus, because I squared is minus, and this half can come down here, minus log of 5 plus or minus 2 root 6 over 2, that's one of the set of solutions, or theta equals 3 pi over 2 add 2 pi n, again that's the general solution, minus I log 5 plus or minus 2 root 6 over 2. And sorry, I've just missed an I off here. So that's an I as well, because we got the I here. We multiply top and bottom by I. So these are the sets of complex solutions here. So theta equals pi over 2, add 2 pi n, minus I log 5 plus or minus 2 root 6 over 2. Or theta equals 3 pi over 2, add 2 pi n, minus I log 5 plus or minus 2 root 6 over 2. They're the complex solutions, and the real solutions we've already got are here to this equation here. Okay, well I hope you found that useful. If you have been able to do that without error, then you can consider yourself very good at finding complex solutions to trig equations. Okay, if you like this, please press the little thumbs up button and subscribe to the Gresty Academy YouTube channel. Thank you.